Hello? Okay, before we started, yeah, I have some small short recording for the question that for the lab 2. So if you want to review how to do the question 3 to 5, just simply click the link here. It will direct you to the YouTube link, because I think some students may have not enough time to like have a look of all the recording of the lab. So I've just cut a part of the lab into short videos, so you can like easily find the solution for each question. Okay, it is on the GitHub link. I will send the link again. As you can see here, just open the link. There are 3 short video for the question 3 to question 5. They are all about 5 minutes long. So if you don't have time to go through all the content at the lab, probably just have a look of these short videos. Let's get started. For the second lab, it will be a little bit complicated than the previous one, but we will go through from question 1 to question 5. Yeah, but be careful. We do not need to submit the exercise 1 and exercise 2. Strongly recommend you to have a look of it. So before we do the question 1 and question 2, we need to know what is HTTP. So if you are not familiar with this, you do not know what is HTTP, what is the data code, probably you need to have a look of the lecture notes. I will also do some explanation here. Oops, let me open a whiteboard. So what is HTTP? Let's say you and Google. So there are 2 machines in here. The first one is you, and another one is the Google. So if you want to request the web page of Google, so what happened? Because our computer does not speak English or other languages. They have their own languages, right? So they can use HTTP as their protocol to communicate with each other. So now we are not care about the how they transmit the data. We just care how they send the web page to us. So we can send a request to Google server with a HTTP protocol called HTTP. It just, you can consider it as a kind of language. So they send some stuff on the HTTP format, so the Google server can totally understand what we are asking for, and it will reply us with the same HTTP protocol content. So our browser can easily understand what is the response. So that is HTTP protocol. And what is request and response? Just here, when we send a message to the Google server, we call this a request. And the response of this request is the response. Seems I'm talking something very stupid. Yeah, and the next one is what is data code, status code. Yeah, because in the response, as the data code is only in the response. In the response, we design a data code to help us to easily identify the results of the response. Like the normal response data code should be like 200, which means our request is successful. So we got a good response. And you can also see some data code start from 3 or 4 or 5. If it start from 4, which means you have some trouble on the request. So you send an invalid request if the data code start from 4, like 400, 41, 42, 43. And yeah, and this next one is the data code start from 500, like 503, which stand for the internal server error, which means the server side have some problem. In this side, they have some problem, and they will reply the data code 5 start from 5. So is this make sense? And when the data code start from 3, it is always redirect you to another web page. And when it start from 4, which means your request have some problem in the client side, they found some problem. And when it start from 5, which means in the server side have some problem. So just remember this because this one is pretty important, no matter in the middle exam or final exam. So if you do not familiar with the code, probably you need to have a check of it. But for now, all we need to know is for probably the 200. Just remember what is 200. It means success, okay? And the last question, what is telnet? Do you have any idea what is telnet? Okay, so if you don't know, don't worry, it should be pretty easy because in exercise 1 and exercise 2, we will use telnet to help us to make a request. So in normal way, if we want to access the web page from Google, so we will start from our machine and then we open our browser like Chrome or Firefox, and then we type the URL, right? And it will directly to send a request to Google, and Google will reply us with a response and show on our browser. So that's the normal way we use Google. But what if we do not have any browser? We have only the, let's say, the terminal. We can't access other stuff. How can we request a web page? So we can use the terminal tool called telnet. So we can use this tool to send a request to Google, and Google will also send a response to us. So we can use Telnet to make a request and receive the response from any server we want. So it's just like a browser, but it's not very easy to use. So in the exercise 1 and 2, we will have a look of it. Let's do the exercise 1 first. So we need to open this one, a terminal here. So if you do not have any VLab environment now, you should install the VLab right now. The simplest way to run the VLab is to find my lecture here. Go to the slides. I gave a link here. Just click this link, VLab Gateway. This link, so you can access your VLab with this web page and do not need to install anything. Yeah, seems some problem here. I will rerun it. Okay, and just log in. So let's run the terminal at first. And just follow the instruction here. Run the command of Telnet. Run this command. Then we will run the second command under the Telnet here and see how it goes. Let's back to the terminal here and run the telnet command above telnet mission the ucla.edu and A0. So do you know what is A0? The previous one, this one is obviously is a URL, but what is A0? A0 is the port number. So you need to be aware of that. The A0 is a common port number for the server. Just enter. So we need to put the second line, which is a request. So we will get HTTP. The version number is 1.1, and the host name is region.ucla.edu. And you need to put to enter to send the request. So here are the response from the server. As you can see, it is in the HTML format. So there are two parts of the response. The first part is the header. So it has some metadata of the response. And the second part is the data on the server. So basically it's the payload of the web page. So here are the content we are requesting, and here are the headers of the response to describe what is this response. Okay, and what we care about is basically the header part. So you don't need to have a look of the body part right now. And we can have a look of the exercise 1. You can see the content type, or can you find a way to get another web page, or yeah, why should we have the cost included? I think question like this. So for the question 1 and 2, you can easily find the answer in the header. Like you can have a look of last modify. What does this mean? Which means this web page has been modified at this time. And the E tag basically is an identity of this web page. Once the content changed, the E tag will be different. So if they change anything on the content here, the E tag will be different. And the content length is which means there are around 5,000 bytes for the content. The content type, yeah. So just go through it. Make sure you understand each header on it. And let's go to the question 3 here. So with the telnet command, can we find a way to get a people.html? So we can try to go to this web page on our browser, vision.ucla.edu. Sorry, no dots. And we don't need to put the port number because the browser will know it is this web page. So in the telnet command, we request this web page. Here, as you can see, the content is the same, but our terminal cannot show the format of HTML, but you can see the content is exactly the same. Right? They have the same paragraph here. So how can we go to this web page? This web page. As you can see, the URL has a little bit different. They go to people.html, but how can we request it on the telnet? Let's have a carefully look of this request here. So you may notice that this part, so what does this mean? So basically, this means we are requesting for the root of this web page, which is this one. So we are requesting this page, but what if we want to go to the people.html, people.html? What should we do? We just put the people.html at this place, then we can send a request for it. So let's try it. You need to add something here. So just go through the same command, telnet. And send a get request for people.html. And with the HTTP protocol 1.1 and the host is vision.ucla.edu. Enter for twice, then you can see here are the response, a lot of name. Can we see Renault parent, the web page? You can see, yeah, probably go to the net office, have a look of the header. But yeah, but we can make sure they have everything in this web page. So we have successfully made the request. Just go back to the header of it. It's pretty long because it has a lot of people and the information and the link here. Okay, here are the header. So here the response header, you can see the status code is 200 OK, which means we made the request successfully. And the E tag is something like this, the content length, and yeah, just go through it, make sure you can understand what is the request. But yeah, that's basically how we send the request command to a server. And this one is also very important because it's the basic of HTTP, and yeah, it will be a frequently asked question on the midterm exam and final exam. Make sure you understand what is this, how can we send a GET request, okay? And let's go to the question 2. Just repeat the step for google.com and see does they set a cookie for you. So yeah, let's do it. What should we do is do the same thing. So just tell that tuition.ucla.edu. No, not this webpage, sorry. .com.au. Not sure where is the webpage. Yes. And A0. Then we can send a GET request. 1.1 version. And the host is google.com.au. Okay, here the response is too long, so because it's very complicated, so we are not looking about the content of it. We just care about the header. Okay, and here are the header. You can see a header here, set cookie. So what does this mean, set cookie? This set cookie. Because Google want to remember us, who is us. Like they want to recognize every customer. So they send a thing called cookies to us. So we can use these cookies to tell Google who we are. Like if you log into Google, how can Google remember you? They are not recognizing the IP address because they may have several people using the same IP address. So they can use cookies to identify each user. But in reality, it's much complicated. But in here, you can just simply understand the cookie can help server to identify their customer. So in the second exercise, is that does it send us cookies? Yes, they do. And yeah, just play around with the telnet command, and it can help you to understand the request and the response of HTTP. So do you have any question for the exercise 1 and exercise 2? Okay, since we have no problem, yeah, once you getting familiar with the HTTP command, that should be easy for you. Just make sure you play around with the telnet for at least once, okay? Understand what it is. But yeah, but we are not going to test you with it. But for the exercise 3, make sure you put it in your report. And again, we don't need to put exercise 1 and 2 into your report. Just start from exercise 3. So exercise 3, what should we do? Let's have a look of it. Yeah, so for the exercise 3, we need to have a look what is the Wireshark and how to play with the Wireshark. So you may need to install the Wireshark on your computer. So if you are using the Windows, just simply go to the Google and search it for the Wireshark here and download it. Download the 64 bits or 32 bits, depends on your processor and CPU, and install it. And once you've done the installation, it'll be something like this. Okay, then you can try with your own computer. First step is click here, click the capture options here. Then you can see a lot of interface in your computer, probably one or two, not sure. But for me, I have a lot of interface here, and I am using the Wi-Fi to connect to my router. So yeah, let me just select the Wi-Fi. Then you can see the stop button here. I select my Wi-Fi first and click the stop button. Then you can see lots of traffic in this window, which means my computer is communicating with other server. And in the left-hand side, you can see the source IP, and here is the destination IP, which means from this IP address, they are sending a packet to the destination IP address with the protocol of UDP or TCP or other protocol, and the length is how much. So that's how we use Wireshark to capture the file, to capture the packet. So I want you to be very clear with it. So that's what happened. Once we run the Wireshark in our computer, it will be in the middle of everything from your computer to the server. So no matter what kind of application you are using, like a browser or the telnet command or other stuff, they will go through the Wireshark at first in your computer. Sorry, it's very ugly. And then the Wireshark will send the packet to the server. So that's why the Wireshark can capture all the packets from your computer to outside or outside from your computer. So it will stand in the middle of the traffic, and all the traffic should go through with it. Or the Wireshark can even capture the packet that is not go through to your computer, like you are in the same Wi-Fi environment. You can even use Wireshark to detect others' packets. Like if you input your password to Google, and I am using the same Wi-Fi with you, then I probably can like detect the packet from your computer to the router and capture it, and probably can get a password of it. So that's how we use Wireshark. Just make sure you can use your Wireshark on your computer and play around with it. Yeah, but it's not very dangerous, but because I say I can use Wireshark to capture the packets, but we have some security methods to prevent this happen. And most of the network interface does not support us to capture the packets from other computer. Yeah, so don't worry too much about it. But yeah, just be cautious when you're using the public Wi-Fi. Someone can capture your packets from your computer to the like Google server and get your password or even get your cookie and pretend they are you, and yeah, and steal your thing. Yeah, this will be the like further information that you will learn in the lecture. So for now, we just need to understand what is Wireshark and how it works, how they capture the packet. Okay, so, and make sure you install the Wireshark in your computer and play around with it. So close my Wireshark now. And then we go to the exercise 3. Yeah, because we need to do the VLab in the exercise in the VLab. So the first stuff is to download the trace file. I have already downloaded it, so I put it in my desktop. For you, just go to the web page and click the link and click the download button. Then you will get it. In the VLab, just simply double click it. Then you can open it. Yeah, or if you cannot double click it, if you have some trouble on opening it, just open the Wireshark at first. It is in this menu, just find it. And then click the file and click the open button here, or you can use the Control O to open it. And find the trace file you want and open it. So that's the way how we open the trace file. So you can see a lot of packets are inside this trace file. Because we are only care about the HTTP command right now. We don't care how they establish a TCP connection and how they close it and other stuff, how does the DNS work. So in here, we will apply a filter here. How to apply a filter? Because all we care is about the HTTP protocol. Just simply type HTTP here and apply the filter. Then you can see only 4 packets left. Then we can have a look at it one by one. Yeah, just have a look of the information here and the source IP and destination IP here. We need to know our own computer is in this IP address 192.168.1.102. This one. This is our computer. And the destination probably is a server IP address. So just make sure you can understand, this one is from us to the server, and the second line is from the server to us, and the third line is from our computer to the server, and the server to us again. So the first one should be the request, and second one should be the response, and third one the request. Last one is the response. Is it make sense? So we can have a look of the IP address to figure out, is it a request or response? And then we can have a look of the information here. It is a GET, right? It is a GET, which means we are requesting this web page. And we can have a look of the details here. Just look at this area and expand it. You can see the request detail, the header of it. So we are requesting this web page, and we are using the user agent of Mozilla 5.0. Usually it's a Firefox or something. And the other headers, is it any important stuff? No, I don't think so. The only thing we need to have a look is the keep alive. What does this mean? Connection keep alive. Because we may need to, may want to like communicate with the server for a long time instead of just asking for once. So we will ask the server to open a connection with us for 300 seconds. So they will hold the connection for 300 seconds. And have a look of the second line. Can we have a look of something interesting thing here? Base, server name, and last modify. Yeah, the last modify, which means this response, the content of this response is modified at this time. And the identity of it, we call it E tag, is this and the other stuff like the connection type and the content type, it's like this. And the third one, have a look of this one. It's also a request, right? We are requesting for the FAV icon. So basically, it's the icon of the web page. Just an example here. We can open a random page. Let's call it. Go to the UNSW. So what is the FAV icon? So we will request if we are using the browser, they will send this request after we open a web page like this. So what is the FAV icon in here? I can tell you it is the icon of this web page. So this is what we request. This one, this icon is what we request. So is this make sense? So in the third request, we are requesting for the icon of the web page. And then what is the response? It said 404 not found. So they have no icon for that. So you will leave to the blank like this. If they are blank in the Google, it will show like this. This one is the blank. So if, for example, for the US view, they do have the icon. So it will show something like this. And the response will be 200. Okay. And if they say 404 not found, which means they do not have icon, and the Chrome will just show a default icon. Okay, so now we can fully understand what is the request and response now. So we can go to the question here. What is the status code and phrase returned from the server to the client browser? Because we only care about the first request and response here. So what is the status code? It's very obviously, right? So I don't think I need to explain that. And what is the HTML file? About the last modified stuff. And do they have a date header? And what is the difference? So they ask us to compare the date and last modified. I think I have already told you what is the last modified mean, right? And the date, what is the date? Which means the time that the response has been made. Okay, so clearly they have difference. And the connection, yeah, for the connection, is it persistent or non-persistent? Then you should have a look if they have the keep alive header and what is the value of it. Okay, just have a look of the keep alive stuff. And how many bytes, that we don't even need to have a look of it. It's just asking about the content length. And what is the data contained inside the HTTP response packet? And you need to have a look of the data in the package. So how can you do that? Just open the content here, right? And what is the content? Then you can have a look by yourself. Easy, right? So we just need to focus on the line 10 and 12 and see what is the request and what is the response. Then exercise 3 should be easy for you. So do you have any question for the exercise 3? Yes, so if you have any question, just feel free to type and open your mic and talk with me. So now I'm going to the next one, but yeah, if you have any question, just post it. So now it's exercise 4. Yeah, just doing the same thing with wild shark, but open another one. So let's go to the Lab again. Here. And we will open the second trace file called trace2. Okay, you can simply download it from the web page and open it. We will apply the same filter. Yeah, let's just delete the filter at first. Then you can see that there are 20 packets in the trace file, and we only concern about the HTTP packets. So we apply the filter like this. And the same thing happened. There are 4 packets in the trace file now. So just have a look of the source IP and destination at first. There are 2 different IP, and we think this one, 192.168, is our IP address, and the 128 one is the server. So we are sending a request at first, and then the server responds us, and then we send another request again, and they respond us again. Yeah, so that's what happened. Let me draw something. This is us. And the other one is, this one is the server. We can call it. And this one is the server. So what happened was, is we send the request and they respond to us, and they send the request again and response again. Is it right? But can you see any difference of these 2 requests and response? Can you see any difference on here? Yes, so the main difference of it is 200 and 304. So let's have a look of it. What happened? So the first request is to get a web page, right? This web page, the Ethereal Labs lab2-2.html. And we can have a look of the headers here. So basically it just request the web page here. Nothing special, just keep alive. And yeah, accept this kind of response. Yeah, nothing very special. Then we can have a look of the response here. It just said our server is this and the date is this and the last modified time is this, which means our content is the last modified date is like this, and the ID of the content is this. And is there any other thing special? Nope. So let's go to this request here. So you can see the request is the same. Can you see that? Yeah, because the request is the same. So why the answer is different, we need to figure out if the request is the same stuff, but you can see the length is a little bit different, right? So they must have some difference on the header here. As we can see, compare them, you can see if the header is a little bit different in here. So they call if modify things and if non-matched. So what does this mean? So it means we are basically asking the server, hey, we are requesting the same web page. But we have already get it. Did you change anything with it? And then the last version we have is this one, and the modified time is this one. And we are asking the server if they change anything after and from that time and with that ID. And here are the response 304 not modified, which means they did not modify anything. Okay. And their only header we need to have a look of is this one, the E tag. So the server just responds us and tell us, oh, there's nothing changed for the same HTML. So we don't need to send you the stuff again. So you can see this length is very short, right? Only 200. The normal length should be like around 700. So they save some data. Okay, so let's back to the picture here. Now we know what happened. Let's put some stuff here, like here in the first line, we just get the page, right? In the, the first line. And the second line, on the second line, is just the response. They just send us the web page, right? And the third line, we ask about the change of it. And in the last night, they told us 304 not modified, which means nothing changed. So that's how it works. So if this picture, probably you can fully understand what they are talking about. So the first line is the request, first packet. So we are asking the server to get a page, and the server responds us, and then after a few seconds, we request it again and ask about the server, is there any change for this web page? Because we have already got it. And the server told us, oh, nothing changed. So we do not need to show any difference on the web page. So that's how this works. And if you can understand what happens here, then you can answer the question of question exercise 4. So the question 1, can you see the header? Right? We have already had a look of it. So I think you can answer this question by yourself. And the question 2 is, does the response indicate the last time and the requested file was modified? Yeah, you just look around with the header, then you will get the answer. And the question 3 is about this part. The third line, we are asking about the change, right? So what did we say to ask this question? Do you still remember? So we can see there if modify things and if non-matched lines, right? So that's how we send this question. So just have a look of the header. And this next question is about the status code of the last response. So how the server tells us there's nothing changed? Which status code is server used? And what is the value of e tag file field in the second response? Yeah, just have a look of the e tag and compare them, because we have already know the e tag is basically the identity of the content. If the content change, even only one byte or one character, the e tag will be different. Okay, so any thoughts? So I guess for most of you, this kind of question should be easy once you can fully understand what is HTTP and how they send the request and response. And if you can understand the header, like all the stuff in the header here, what is this kind of header? This kind of question should be very easy for you. Yeah, probably you are like the first time using this kind of software. Just don't be afraid with it. It seems very complicated, but actually it's very easy to use. Just open it and have a look of the data we have inside here. And when you can play around with this by capture the packets with yourself, right? And you can try to capture the packets that you send to Google when you log in and see how your password is sent to the server. So if we have any question, just send it on the chat. Now we are going to the last question. So for the last question, we need to know some basic of programming. So I guess most of people here will know how to use Python, right? So I will made it. I will do an example of question 5 here with Python. Yes, I think so. I'm not sure Python is the easiest, but Python will be the shortest. So I assume you have already know some Python basic, like you know have already know what is for loop, what is if condition, and the like some very basic data type or something. You know what is string, what is int, then you will be fine. Yeah. So if you don't know, just yeah, tell me. I'll explain it. So before we go, just have a look. What is the exercise file here? It's very long, right? Seems very complicated here. Oh, oops, very, very long. So what is this question? Let me show this again. So basically, they gave us a stuff called server. So they gave us an program called server. So now we need to create our own client that can send some stuff to the server. Okay. So what is the interesting of the server? When we send the message to the server, it will print the stuff out and then response us just like the HTTP server. So how can we create our own server? You may say, probably we can use our browser, but no, we are asking you to create a program to become a client that can communicate with our server. So let's start from running the server, okay? Let's have a look over the server at first. Simply download the server from the web page here. Just go to the top. Yeah, it's over here. Can you see that? This stuff. Just click it and download it into your WebLab. And let's go to the WebLab here. So I will delete all the unnecessary stuff. So I guess you have already downloaded into your WebLab here. Then we can run the terminal here, try to compile it. Because it's a Java file, we run the terminal here, okay, and compile it. So how to compile it? We can go to the specification of question 5. The first line is teach us how to compile it. So it's Java C and the file name. Yeah, and simply run it. Then you will find a new file here, which can be used to run our server. So how to run it? Just go to the instruction in the Lab2, but it's very easy to run. Just use Java and the file name. The new file name does not have any dots here. And we run it. It says require argument port. What does this mean? Because we need to specify a port number here, like here, Java ping client host port, something like this, right? Oh, sorry, it's in here. This one, the server port. So how can we do that? We just probably give them a number. Let's say 6666, quadrat 6, and run it. And you can see it seems we stuck here, right? We can't do anything. Doesn't show anything. And yeah, that's how we run the server. So we can see the server is running now, but because there is no request to our server, it will not print any stuff. Okay, so we have successfully run the server. So let's just go to the client side. How can we do the client? So in here, I'm not going to teach you all the stuff because I can't show all the code that we need, but I will show some key step of it. I will teach you how to send a request and receive a response from the server. So if you still have any questions, just feel free to ask me, but I'm not allowed to share all the answer, all the code to you because we will check the plagiarism. So I don't want you to be in trouble if I share all the code. Okay, let me check. In WeLab, I think I should run the terminal of Spider at first. So I run the program of Spider. Spider 3 is the IDE for the Python. Let me run it at first. And let me create new file for the terminal here. Can you see that? I create a new file, and let's say lab2 demo. Because we want to send some stuff to our server. So we will use the library, we call it socket. We need to import the library at first, socket. I'm not sure you can see that. Probably I should make it larger, and so everyone can see it clearly. Is that okay? So if you cannot see them clearly, just let me know. So first step, import the library called socket. So, and then the second step is to do the initialization of the socket. Just the fixed step. All you need to do is remember this step. Then you'll be fine. I create an object called SOCK. Then I do the initiation of the socket class. And yeah, it asks us to put some family and type into it. So it just socket dot af. We are going to send the internet stuff and socket dot sock dgram, I think. So for the first step, we don't need to worry about too much. Just remember it and use it. And we may use the same stuff in our assignment. Don't worry too much if you can't understand it, just doing initialization. So we can use this object right now to help us to send the request and get a response. And the second step, probably we can send some stuff, right? To send something. Let's say so sock dot send to command. So you can see the first item is the data. We need to send the message. Let's say we can send a hello to the address, but we also need to encode the message. It's just a requirement of it because we can't send the string directly. We need to encode into bit and then send it. And what is the IP address of our destination? Be careful, I put a bracket here, which means we are inputting a tuple here. 127.0.0.1 is our own IP address, and the port number is 666. So you may consider, what is this? This one is the address of our server, okay? So we are created the server here at the let me see, at the IP address of 127.7.1. Right? Does this make sense? Because in last lab we already know what is this IP address. It's our own IP address, right? And now we are running a server in the terminal here. Probably I should close this one. This one is running a server right now. So the IP address is our own IP address, which is 127.0.0.1. And the port number is 6666. That is our number here. So I just put it here. So that's why we put this address here. And yeah, and then we can run it and see how it goes. I will make it smaller, put it aside with our server. So the left side is our server, the right side is our client. As you can see, we only write 3 rows here. First one is import the library. Second line is to do the initialization. And third line is to send a message. So let's see how it goes. Let's just try to run it. Okay, so once we click the run button, you can see some output here, and the output in the server here. You can see we send a hello to here, right? And the server send us a reply. So we can keep running it. Let's just change something. Let's hello Lab2 and send it again, see how it goes. Yeah. So now we can send some message to the server. So how can we receive the response from the server? Do you have any idea? So it will be pretty easy. I will add the 4th line to do it. So how to do the receive? Basically just socket dot recv and put a number on it. You can like put a fixed value called 1024. So we will receive at most that much bytes stuff from the server. So let's see how it goes. We can call this one response, right? And we can print it. Let's print the type of it at first, and then print the response of it, and see how it goes. Just run the code. As you can see, I just add 3 stuff. The first row is to receive the response from the server, and print the type of the response, and print the content of response, and see how it goes. And run it, and you can see the server receive us and send us a reply. And yeah, here are the reply from the server. Doesn't make any sense, right? You can see the class is byte, and the hello lab2. So because it's like encoded in the bytes, so it's not a string, it's a byte here. So that's why they have lots of stuff doesn't make any sense. You can decode it and show the normal str. You can do it by yourself. It should be pretty easy, just like how I encode here. Just run the decode command and print the message. Okay. And we can run them for like several times and see how it goes. Server send and run again, run again, run again. Just keep running. Oh, then something happened. Do you see that? The server says we didn't reply you, reply not sent, right? So in here, we don't have anything to print. So you need to make your program can handle this situation. You can see my program is stuck here. The program is still running. I can stop it like this. And it said, I stop it. We stuck on this line. We are still waiting for the response of it. So in here, I can teach you another thing is to set a timeout. We can set sock dot set timeout. Let's say 1 second. So we will not stuck anymore. So let's just try it. with this line. So we set an timeout here. Right? We just because not send we run again and the server does not reply us. And yeah, we will directly have a timeout exception here. It said timeout. So your program will be, you will need to handle this kind of situation. Because once it comes to this line and they did not respond to us, and then our program will like stopped, then you may need to have write something like try and accept, but I'm not going to show you here. If you have any trouble to like handle this kind of exception, just let me know. But I think, yeah, that's what all we need with this library. So I teach you the key step, how to do the initialization and how to send the stuff and how to receive the information. So I guess you can do the lab right now. So just let me know if you have any trouble of it, like what kind of function you are not familiar with. And so we got a question here. Why did the server not reply anything at the end? Yes. So we need to know how does this server work. If you go through the instruction of our lab 2 of the question file, let me find it for you. You just go through this kind of long stuff here. Yeah, it will tell you the server will sometimes do not reply you, like randomly does not reply you, like this. So most of the message will be replied, but some of them will not. It just random selected. Okay, so we need to handle this situation with our client. So that's why, because the last run, the server did not reply us. So that's why we didn't have anything here. And you just say timeout because the server did not reply us in 1 second. So our program just breaked and stopped. Yeah, just let me know if you have any trouble on the programming. I guess the hardest part should be use the socket, right? You need to get familiar with this library, how to send and how to receive. And the second one is probably the try and accept syntax. And the third one is system.argv, how to use the system.argv, because our requirement is we need to run our program like this, run our Python like this, in this command line, right? It will receive two different parameters from the command line. So how can you receive the command line? Then we need to use sys.argv. So if you don't know, just search online and then you can find some example of it. Yeah, and the third one, you may have some trouble on the calculation of the time, because the question is asking us to calculate the round trip time, right? The time that when we send the message and when the response has arrived. So we need to calculate the time. So probably you can set a timer here before or after we send the message. You can add a start equal to what current time, right? And you can put a response here and and let's say current time, then RTT will equal to start probably and minus start, right? That's how we calculate the time. Does it make sense? This one, and this one. You can use a lot of kind of library to get the current time. So I think that's all for the exercise. If you have any trouble with it, just let me know. I will stay here until the end. Yeah, you can even use the decorator to calculate the time if you want. Yes, I guess I will stop the recording here so you can share your screen if you have any trouble.